Algebra 2. We are starting Chapter 3, which is Systems of Equations. So, first we're going to learn how to solve systems of equations. Today we're going to go over graphing, substitution, and elimination. So these are just 3 different methods to essentially find the same solution. We're looking for the answer. If we're graphing 2 lines, where do they cross? Okay, so we're going to do it graphically and learn 2 methods algebraically. Okay, hopefully this is a review from Algebra 1. Okay, so here we have using a graph or table. We're not going to use a table, we're only going to graph here. Solve the system. So graphs, we have these 2 graphs, these 2 lines in standard form. We need them to be in slope-intercept form, which is y equals mx plus b. Okay, I'm not going to go over this super in detail with you right now, just because hopefully we know how to do that. If not, a quick review, I'm going to do the bottom one. X plus 2y is equal to negative 8. Okay, we're going to solve for y. Subtract 8, subtract 8. We get 2y is equal to negative x minus 8 divided by 2. We get y is equal to negative 1/2 x minus 4. Okay, here's your slope, here's your y-intercept. So we start at negative 4, we go up 1 over 2, negative, up 1 over 2, negative. Okay, then we graph the red line, which is the top. So this is red, this is blue. Okay, where they cross is at this point, negative 4, negative 2. So that's your solution, that's your answer. Okay, so that's how you do it graphically. But they have to be in slope-intercept form. So you're going to either have intersecting lines, like the previous example that we just did, where you get one solution. Okay, these lines are consistent and they're independent. Okay, if you have coinciding lines, what that means is just one line. Okay, they're the same slope, same y-intercept. There's infinitely many solutions. These lines are consistent and dependent. Okay, and then if you graph it, you get 2 parallel lines. That means they have different y-intercepts, but they have the same slope. So they grow or decrease the same rate. So this is no solutions, and these 2 lines are inconsistent. Okay, so an example of that had to figure out whether they're independent, dependent, or inconsistent without graphing is you can look at their equation. So we have these 2 equations. Again, neither one of these are in y equals mx plus b form. So we have to do that in order to figure out what they are. So here we added the 2x to both sides, divided by 4. Okay. Here we just divided by the 8 to eat both things. Both slopes are 1/2. This y-intercept is 3 over 2. This y-intercept is negative 3 over 2. So they have the same slope, different y-intercepts, so these are inconsistent lines. Okay, so what that means is that they have the same slope but different y-intercepts, so they're plotted. One starts at 1.5, one starts at negative 1.5. They still grow at 1 over 2. Okay, so they're going to be parallel. So they're never going to cross. Now let's practice solving algebraically. First we have substitution. So with that, we're going to plug one equation into the other. You have substitution and elimination algebraically. It kind of depends on your preference or how they're set up, what way you do it. Okay, so like this first one, we have 3x plus 4y equals 12, and then 2x plus y equals 10. With substitution, if you're solving with this method, you have to get y equals or x equals of one of the equations. So neither one of these actually say that. But if you look here at the second equation, we can solve for this y by just subtracting the 2x, and it'll be super easy because there's no coefficient, we wouldn't have to divide. So that's kind of my little hint, is whenever you're solving for a variable here for substitution, check to see if there's any variables without a coefficient. Okay, and the only one here is this y, so if we wanted to get that by itself, which is our first one, for one of the variables we're solving for y, we subtract 2x, so now this is y equals negative 2x plus 10. Okay, so since this is what y equals, we're going to take that and we're going to plug it into the y for the other equation. Okay, so this is where we're going to plug our negative 2x minus 10, because that's what y is, right? And we're going to put it in parentheses. So we get 3x plus 4 and then times negative 2 plus 10 equals 12. Distribute our 4. Okay. Bring down the 3x, negative 8x plus 40 equals 12. We simplify, solve, we get 5.6. Okay. So that's what y equals. We're not done because we need our coordinate point, which is an x and a y. We have y, we need x. Or sorry, vice versa. We have x, we need y. So we take this x and we plug it in for either one of these equations. You can do this one, you can do this one, you can even do this one. It doesn't matter as long as you plug it in and you do your math correctly. So they picked this x right here. 2 times 5.6 is 11.2. Subtract it over, you get y equals negative 1.2. It's kind of hard to see, but this is your solution, the x and the y as a coordinate point. So 5.6 and negative 1.2. Okay. So let's do a full example together. So we have, what is the solution of the system of equations? And we're going to solve it by substitution. So first step, I'm going to see if any of the equations are solved for a variable. Okay, they're not. It's x plus 3y and then negative 2x minus 4y. But we have this x by itself. So I'm going to solve for that. So that x plus 3y is equal to 5. Subtract 3y to both sides. We get x equals 5 minus 3y. Cool. Now we need to take what x equals, and we're going to plug it into the x in the other equation, which is right there, right? We're going to plug it there. So we're going to say negative 2 times 5 minus 3y minus 4y is equal to negative 5. Okay, now we solve for y. So originally we had 2 equations, 2 unknowns. Now we plugged it in, we have 1 equation with 1 unknown, our y, that's what we're going to solve for. So we get negative 10 plus 6y minus 4y equals negative 5. Combine negative 10 plus 2y is equal to negative 5. Add 10, add 10. We get 2y is equal to negative 5 plus 10 would be 5. Divide by 2. Y equals 5 over 2. Okay? I don't know why I circled that. We're not done. There's our y, but we are not done. We just have our y value. We need our x value. So we can pick any equation. I'm going to go for this one. Okay, so we have x is equal to 5 and then minus 3 times 5 over 2. Okay, so we got to multiply that. I'm going to put that over 1. 3, so x equals 5. And then negative 3 times 5 is negative 15. 2 times 1 is 2, so minus 15 over 2. Okay, I'm going to make this to be a 10 over 2 minus 15 over 2. So x equals, keep, change, change. We get this to be a negative 5 over 2. So our x value is negative 5 over 2, and our y is positive 5 over 2. Okay, so that right there is your answer. That if we graph those 2 lines, that is where our line would cross. Okay. So now let's talk about elimination. So this is, again, just a different method. Same rhyme, but different reason. Right? So same reason, or I guess same reason, different rhyme. So the reasoning of doing this is we're finding x and y where these 2 lines cross. It's just a different method. Okay, sometimes it's easier to do it this way with elimination. So we have 4x plus 2y equals 9, negative 4x plus 3y equals 16. Our point here is to eliminate a variable by adding straight down. Okay, so our x's are lined up, our y's are lined up, and our constants are lined up. So if we add straight down here, 4x plus negative 4x, that cancels. And that's the purpose of elimination, to eliminate. So we have 2y plus 3y is 5y, 9 plus 16 is 25. Here we divide by 5. 25 divided by 5 is 5. Okay, so we have what y is. Now we need to back solve to find x. Same thing with substitution. So pick an equation. It does not matter which. As long as your math is correct, you're correct. Okay, so I'm going to pick the 4x plus 2y equals 9. So plugged into the 5 right there. So 4x plus 2 times 5 equals 9. So 2 times 5 is 10. And then we're going to subtract 10 to both sides. 9 minus 10 is your negative 1. Divide by 4, we get negative 1/4. So that's why your answer is negative 1 over 4 is your x, and your y is 5. that's your answer. Okay, so let's do another elimination, a little bit harder of one together. So we have 2x plus 7y is equal to 4. And then we have 3x plus 5y is equal to negative 5. Okay, so if you look here, if we add straight down, 2x plus 3x is 5x, 7y plus 5y is 12y. Okay, nothing eliminates. So we need to do some manipulation to these equations. Okay, so I'm going to look what, these need to be opposite. So like the previous one, it was 4 and negative 4. Those are opposite numbers. So these need to be opposite. So positive and negative of the same coefficient. Okay, so 2 and 3, they both go into 6. 7 and 5, they both go into 35. Okay, well 6 is smaller, so I'm going to go with that one. It doesn't necessarily matter what you use to cancel, which one you go for. I just like smaller numbers. Okay, so these both go into 6. We want one to be positive, we want one to be negative. Okay, so I'm going to multiply the top by 2 times 3 gives us 6. So then I'm going to multiply the bottom by a negative 2 to get a negative 6. So that would be, and then we just distribute it. 3 times 2x is 6x. 3 times 7y is 21y. 3 times 4 is 12. Okay, now we have our negative 2. Negative 2 times 3x is negative 6x. Okay, that's what we wanted. So if you don't get that, then go back to the drawing board. Negative 2 times 5y is negative 10y. Negative 2 times negative 5, that is bad, is a positive 10. Okay, so add straight down. Oh, looky, our x's eliminate. So 21y minus 10y is 11y equals, I don't know why my smart board is being crazy, 12 plus 10 is 22. Divide by 11, y equals 2. Okay, not done. We have our y, we need our x. So we can pick, we have 4 equations we can pick. This one, this one, this one, or this one. Okay, with your originals, those are going to be your smaller of the numbers. I'm just going to pick the top. 2x plus 7y is equal to 4. We said y was 2. So 2x plus 7 times 2 equals 4. Okay, so 2x plus 14 equals 4. Subtract 14 to both sides. We get 2x equals negative 10. Divide by 2. X equals negative 5. So your answer is negative 5, 2. Okay, so if we were to graph these two lines on the same graph, they would intersect at the coordinate points negative 5, 2. Okay, so that is lesson 3.1 to 3.2. Hopefully that helps with what we're doing. So now your assignment is to go to MathXL. You have 12 total questions. Sorry, it's more than 10, but it's only 2 more. So you guys are awesome. Do great. See you later.